Dear all, welcome again to Yella Academy of Competitive Examinations. This time to the post on Unit number 6 Cbse Class 12 Introduction Content. Classification on the basis of number of halogen atoms. Haloalkanes or haloarenes are classified as mono, di, tri, polyhalogen compounds depending on the number of halogen atoms in their structures. For example, if it is a monohaloalkane, there will be only one halogen atom bonded to an alkyl group. If it is a dihaloalkane, listen to me, there will be two halogen atoms bonded to two different carbon atoms. For example, 1,2 dichloroethane. The another example can be given if one carbon holds the chlorine atom, another carbon holds the bromine atom. We can name this compound based on IUPAC rules, that is based on alphabetical listing. 1 bromo 2 chloroethane. Since there are two carbon, that is ethane, we can give 1 to bromo and 2 to chloro. 1 bromo 2 chloroethane. Trihaloalkane. If there are three halogen atoms, the three halogen atoms can be same or different, bonded to three different carbon atoms. For example, 1, 2, 3 trichloropropane. 1, 2, 3 trichloropropane. Since there are three carbon atoms, we use the name propane. It is saturated to, that is single bond. There are three chlorine atoms bonded to first carbon, second carbon and third carbon, hence the name. Now we look into some more examples of it. If there is one chlorine atom, if there is another one is an iodine atom, that is an halogen bonded to the carbon, here the preference goes to chlorine. See, 1 chloro 2 iodoethane. In case of compounds having 4 carbon atoms, the chlorine, the same halogen atom, is bonded to 3 different carbon atoms. We have to take the least numbering 1, 2, 4 and not 1, 3, 4. That is 1, 2, 4 trichlorobutane. If the halogen atoms attached are different, as I told earlier, the preference of alphabetical listing follows as per IUPAC, that is 1 bromo 2 chloro 3 fluoropropane. Again I repeat, 1 bromo 2 chloro 3 fluoropropane. Now we'll come into haloarenes, ARX, that is halogen atom bonded to an aryl carbon. Aryl refers to C6H5, that is phenyl. X equal to chloro or bromine or fluoro or iodo. Yes. If it is a monohaloarene, X directly attached to the benzene ring. Here all the 6 positions are equivalent in case of mono-substituted benzene ring. Okay. If it is 1, 2, the first position and the immediate adjacent position, hence we use the name 1, 2 dihaloarene. For example, if I put in the place of XCl, it is 1, 3. Look into the last structure, it is 1, 3 dichlorobenzene. Why dichloro? There are two chlorine atoms and it is bonded to position 1 and 3. 1, 3 dichlorobenzene. Now we look into some more examples. If the halogen atom is bonded to position 1 and 4, it is 1, 4 dihaloarene. That is, if it is Br, bromine, 1, 4 dibromobenzene. Similarly, the next case, trihaloarene. 1, 2, 3 trihaloarene, where X can be Cl or Br or F or I. Now we look into our next topic, compounds containing sp2 hybridized carbon bonded to an halogen atom. That is, compounds containing sp3 hybridized carbon to which an halogen atom is attached. In alkyl halide, the halogen atom is bonded to an alkyl group directly. They form an homologous series by the general formula CnH2n plus 1x, where n refers to number of carbon atoms. The first classification is primary, secondary, tertiary alkyl halide. I use We can memorize this easily. If the halogen atom is bonded to a carbon having two hydrogen atom, it is referred as primary alkyl halide. That is, it will have only one alkyl group if an halogen atom is bonded to a carbon having two hydrogen atom. On the other case, the second scenario, if the halogen atom is bonded to a carbon having only one hydrogen with two alkyl groups also attached to that carbon, it is referred as secondary. Again, if the halogen atom is bonded to the carbon bearing or having no hydrogen atom, it is called as tertiary. In this case, the carbon atom will be bonded to three different or same alkyl groups. The second classification under this is allylic halide, that is halogen bonded to an allylic carbon. Halogen atom is bonded to sp3 hybridized carbon atom adjacent to carbon-carbon double bond. That is, the halogen atom is bonded to a carbon which is adjacent to carbon-carbon double bond. That is referred as allylic carbon. Here the allylic carbon is sp3 hybridized. For example, we see an example 1-chloro prop 2-ene. Here the double bond is in position 2. The halogen is attached to carbon 1, hence 1-chloro prop 2-ene. Also in the case of aromatic system, 1-chloro X2-ene. 1-chloro X2-ene, that is hexene. 1-chloro X2-ene. Here the position of the double bond is 2. The next classification is benzylic halide. Here the halogen atom is attached to a side chain carbon which in turn is attached to an aromatic ring. Halogen atom is bonded to an sp3 hybridized carbon atom attached to an aromatic ring. For example, benzyl bromide. Here bromine is attached to a carbon. That carbon in turn is attached to an aromatic system, that is to an aromatic ring. The last part of a classification comes under compounds containing sp2 carbon which is attached to halogen bond, Vinylic halides. Compounds in which the halogen atom is bonded to sp2 hybridized carbon atom of a carbon-carbon double bond. Here the halogen atom is directly attached to the double bond, that is chloroethene, or we can have an aromatic system too. Next, the last topic coming under sp2 carbon bonded to an halogen atom is aryl halides, compound in which the halogen atom is directly bonded to sp2 hybridized carbon atom of an aromatic ring, that is bromobenzene, etc. Okay. Thank you for viewing our channel. The next topic will be on IUPAC nomenclature of haloalkanes and haloarenes and the structure of the functional group of haloarenes and haloalkanes and haloarenes. Thank you.